Okay, regression analysis. Regression analysis is a mathematical measure of the average relationship between two or more variables in terms of the original units of data. Regression analysis is the mathematical measure of the average relationship between two or more variables in terms of original units of data. Also, we can define regression analysis statistical techniques that is very useful for exploring the relationship between two or more variables, one independent variable and the one dependent variable. Regression analysis is a form of predictive modeling techniques which investigate the relationship between a dependent target and independent variable predictor. This technique is used for forecasting, time series modeling, and finding the causal effect relationship between the variables. For example, relationship between rash driving and number of road accidents by a driver is best studied through the regression. Regression analysis, dependent variable, independent variable, positive relationship, negative relationship. Linear regression, if the regression curve is a straight line, then there is a linear regression between the variables. Non-linear regression or curvilinear regression, if the regression curve is not a straight line, then there is a non-linear regression between the variables. Linear is linear, it's a no linear relationship. The equation of straight line y equal to mx plus c, where the independent variable y is plotted as a result of changing the independent variables x. Sorry. The equation of straight line is given by y equal to mx plus c, where the dependent variable y is expressed as the result of change in the independent variable x. With two variables x and y, one can have the linear expression equation, regression equation y on x, and regression equation x on y. When it is required to estimate y for different x values, treating y as independent and x as the independent variables, when it is required to estimate y for different x values, when it is required to estimate y for different x values, treating y as dependent and x as an independent variable. So regression equation of y and x, that is y equal to a plus bx, when A and B are constant and is the intercept of the regression line on y-axis and B the slope of the line. When x is taken dependent and y is independent, so regression equation x equal to a dash plus b dash y is estimated for the different x values. A is the intercept of the regression line x and y in x-axis, and b dash is the regression coefficient of x and y. To obtain the regression line y and x, the slope of the line an and intercept on the y-axis b are given by the formula b equal to y bar minus ax bar, where x bar is the mean of the values of x1 and y bar is the mean of the values of y. An example, x1 and y1, 1, 2, 3, 4, 5, 9, 8, 10, 12, 11, x1, y1, x1 square, y1 square, x1, y1. So we can calculate x bar and y bar, that is the mean summation x1 over n, summation y bar over n. Substituting these values in equation 1 and second, a equal to n summation x1 y1 minus summation x1 summation yn over n summation x1 square minus summation x1 whole square. B equal to y bar minus ax bar. So B equal to y bar 10 minus x bar a 0.8 x bar. So B equal to 7.6. So the equation is straight line y equal to x plus b, y equal to 0.8x plus 7.6. If the value of variable y1 was 13, then the estimate variable x1 would be 13 equal to 0 point at x plus 7.6, so x equal to 6.75. Well, okay, it's all about regression analysis. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. Let's now bye bye, children.